A woman looking away. Young or old? Young woman. Who sees the young woman? Who sees the old woman? Okay. Who sees both? Okay. Of those folks that see both, have you done this before? Okay, cool. Now, here's the deal. Old woman. The old woman's mouth is right here. If we can get this in, great, that was in red. Okay, mouth is right there. The old woman's nose is right there. It's got a wart. Okay, it looks like, the wicked old witch, right? Chin. Her eye. Do you see the old woman? Slowly? Feeling better now about the old woman? No, are you kind of half wondering why you didn't see her before? Now, young woman. Young woman. Forehead. Side where her eye is. She's looking away from us. Cheek. A little bit of a bump from the nose. Jawline. Her ear and her hair is running away. She's looking back over her right side. This is a choker that's on her neck, not a mouth. Those people who saw the old woman and didn't see the young woman, do you see that now? Crazy, right? Now, keep in mind, every time you do something, the first time takes longer. First time you reread your notes takes longer. The next time you're more familiar with it, it's a shorter amount of time. The next time, shorter. How do we know? Because when I go on to something like that, and I say, find the old woman and find the young woman, it's faster this time. Can you see them both? I have them looking the same way. It's the same gender. It's just a little change in the picture. Are you feeling okay with it? Can you look about the jawline and see both of them at the same time? The jawline of the younger woman. Do you see it? Now, that was fast, right? Way faster than the first time. It's like rereading your notes, doing it again. But more importantly, it's about an experience doing things each time. The first time you did any type of skill set, very few people, like pick up swimming. If I threw them in the water, they would be a rock. But as they practice, as they float, as they get better, as they work harder, they get it. Okay, it becomes easier. The more experience you have, the easier a 50 becomes. You swim 100, you swim a 200. Maybe you'll swim a 500 for your first time nonstop. It's a big deal. But there are some people have been swimming 2, 3, 4,000 yards or 5 miles at a nonstop, but they don't start there. They start one thing at a time. Okay? I'm asking you to reread your notes. It's all about you making sure you're taking care of you, but rereading allows you to learn the material, and then as you reread the next day and the next day, your learning becomes actual learning, and you're retaining the material you're supposed to be prepared for the test. But more important, everything we do in here, the first time it's slow. The next time it's a little faster, and the last time, the third time, now I get a different gender, I'm looking the other way. Do you see the old man and the young man? With a lot less work, right? Now, I'm not saying this easy. I am saying, however, that as we go, we have to work for it. We have to want it. We have to make decisions for it. Got to get it done. Now, today is a knee-jerk reaction to the quizzes I graded last night. We need inverse, we need converse, we need contrapositive work. Changed what I was doing, and in such a way to make it work for that review and notes that you're going to have to kind of scribble a couple things out as we go in notes today, because I'm making changes. Okay, first one's not so bad. This stuff is right here, and I'm going to talk about this stuff over here on the left board as you're writing it down. We're talking about biconditionals today, and people aren't paying attention to look at it and go, Bloom, you misspelled if. I mean, how bad is that? No, it's IFF. It represents if and only if. And I actually got it marked on your notes right there because it represents if and only if. Okay? Now, biconditionals are good definitions, which means you have a forward sense of the conditional, which is the original if-then statement, P implies Q, and you have the reverse sense, which is converse, which is Q implies P. Okay? P double-headed arrow implication, Q is a biconditional. And it's a true double arrow. If it's a true biconditional, it's a good definition. Okay? Now, if both forward and reverse evaluate true, then P with that double-headed implication arrow is true as well. Okay, you have a true biconditional. That's in a nutshell is what we're doing today about our notes. But I'm also going to go over inverse, converse, and contrapositive. So we're going to make that happen too. Those are the things I just went through up here and down here. Are there any questions so far? We doing okay? Write the converse of the following true conditional. I'm saying it's true. I want the converse of it. I originally have if the sum of the measure of two angles is 180 degrees, then the two angles are supplementary. If I'm supposed to write the converse, okay, this is my original conditional. If this is my original, which is P implies Q, my converse is Q implies P. I switch them, but now I switch not a wholesale all the time. Sometimes I can, but readability has to come in, okay? And on this one, it's pretty nice because I've got the sum of the measures of two angles is 180, then the two angles are supplementary. So I'm still talking about two angles. So I'm looking at if two angles are supplementary, then the sum of their measures is 180. Okay, so I've written the converse. Gentlemen, please pay attention. I've written the converse as we're going through. Now, to determine the truth value of the converse, it's true if the converse is true. You can form a true biconditional by joining the original hypothesis. The sum of the measure of the two angles is 180 degrees. That's my original hypothesis. The original conclusion, the two angles are supplementary. Okay? If I were to write this in if and only if, this is how I do it. I get rid of the if, I put in if and only if at the then, and I'm pretty much done. And I write it in the original sense, the original direction sense. The sum of the measures of two angles is 180 degrees if and only if the two angles are supplementary. This is a true biconditional statement. It is a good definition. Now, keep in mind, part of today's notes, we're going to talk about inverse, converse, contrapositive, and then we're going to talk about how they're interrelated with biconditionals. So make sure we're getting that stuff done, okay, as we're going through. Now, I want you to define P and Q. In this particular thing, this is a biconditional, and P, let me get it in red. All right, I keep grabbing that, and I think it's the red, so let me flip-flop these things. Okay, P, double-headed implication arrow, Q. So P is the first part, Q is the second part of this statement. So look at that and decide what the first part is and put it on the line for P. Look at it, decide what the second part is, and put it on the line for Q. Some people are like, that's it? I was like, that's it. I'm just asking you to define P and Q the way I have them written. Okay? If this is P, that's Q. This if and only if represents the arrow. If and only if. So the stuff before the arrow is P. Array is an angle bisector. The stuff after the arrow is Q. It divides an angle into two congruent angles. And people are like, that's all you're asking? Yep, that's all I'm asking. But in this experience, people have to have, like we did with the faces at the beginning, to make things more easily understood. Okay, if you don't experience stuff, we're not learning stuff. Now, for some reason this fell away. This fell away. Good, that fell away. I was just wondering what I did with that. Now, writing the forward sense. When I say that, that's the original conditional. And please notice I gave you a biconditional statement. The biconditional statement I gave you has the original in there. All I have to do is put if at the beginning and then where I see the if and only if. So that's what I did when I wrote it. Okay, I have people that will freeze on the test and go, boom, I don't know what to do. I was like, well, you didn't do your notes. You gotta make sure you follow through because it's subtle. Hey, write the original. Write the forward sense. Write it in if-then form. Those are ways I can ask you to take a biconditional statement and put it in the original P implies Q form. Okay? But if you don't have the experience with it, you're lost. Now, when I ask you to write it in the reverse, I'm asking you to use the converse. The converse is Q implies P. We already got Q, we got P. Go ahead and write the converse. And the converse is an if-then form statement where Q is first and P is second. Where Q is first, Q, it divides an angle into two congruent angles, and P is second. Array is an angled bisector. But I have to have it in if-then form. If array divides an angle into two congruent angles, then it is an angle bisector. Now, I have some folks that are like, okay, this is starting to get a little bit better. I understand it. There's a formula for this. Okay? The formula that we have, if I have the original statement, I have Q, P implies Q. If I have the inverse, I have something called not P implies not Q, and that is a del that we have in front. Give me a sec, Dubay. Okay, I have the converse. The converse is something where I switch Q and P. And then I have something called the contrapositive, and everything that we write is always based on the original. Positive. Somebody kind of spell positive here. So contrapositive is not Q implies not P. Okay, that single arrow as we're going. So I've got the converse. If array divides an angle, and remember array is an angle bisector. If array divides an angle, because this is the converse, the Q should be first, then it is an angle bisector, and we're set. Now writing the biconditional. You've already done it. But I want you to know that I will ask you today on today's assignment, after you've looked at the forward sense and the reverse sense, forward being the regular, reverse being the converse, and have determined that they are both true. Array is an angle bisector, okay? Then it divides an angle into two congruent. Yep, angle bisector, split the angle into two congruent parts. Now, if an array divides an angle in two congruent parts, then it's called an angle. Yeah, that's true. That totally is going to work. I've got it. And now I take and I write array is an angle bisector if and only if it divides an angle into two congruent angles. And it's the exact thing we started with. I had you break down a biconditional, I had you do the forward sense, the reverse sense, and then I had you rewrite it as a biconditional. So the answer was there. Dubay, did I answer your question, or did you still have it?
I just had a comment about the converse. I mean, like that's a better way to write a converse, because I was expecting you to go like, if it divides an angle into two congruent angles, then array is an angle bisector, because I feel like that's what you usually do.
No, this was a wholesale switchover. Sometimes there's a readability issue,
Yeah.
and we make the change because if I'm talking about if I had it in the second part and I'm talking about array was an angle bisector or something. So this way I had it in there the whole time. So I had it come back in.
Yeah.
And so ray stayed. And what we're talking about is on the converse when we're looking at it. I had ray here and it here, but I had my ray there and it here when I made the change. And I let ray be it on the hypothesis so people knew what I was talking about before I got to the conclusion. I mean, it won't kill you one way. I look at it as called a clunky writing, you know, because if you don't know what we're talking about until after you get to the past the then, I mean, you got to go back and reread a little bit. But that's readability. When I talk about readability, you're making it change. You're substituting the subject for, you know, the it or the them or something like that. So make sure you're careful about recognizing that. But I won't nail you wholeheartedly unless you've changed the idea of the problem and points. Okay? Any other questions? We're good? Promise? This is the section I wanted to redo, so I did. It's not pretty. I recognize it, but I'm okay with it. I've moved on. Here's what I need from you. You guys have a bunch of junk there. I actually just whited it out. Okay, I covered them up. It's actually at problem 8. What I want you to do, you need the original statement. You need the original if-then statement. Please write that down. If a polygon is a triangle, then it has exactly 3 sides. You needed this as a start to this problem. Now, the question here is, really, I want you to write the inverse, converse, contrapositive, and the biconditional if the original and the converse are true of this statement. Okay? Now, the reason I'm doing it this way is because we need to review inverse, converse, contrapositive writing because I had people not really having a great time on that quiz with them. And we should be. After notes on Monday, if you did notes on Monday and had them during the quiz, you should have had no problems whatsoever with it. Okay? But if you're kind of sketchy and you didn't do the video, but you did the PDF because it was easier, but not as informative, yeah, it did okay. Here's the deal. When I'm looking at this, if a polygon is a triangle, then it has exactly 3 sides. The inverse, I negate the hypothesis, I negate the conclusion in the same order. So I don't do anything. That's what this little del does. If a polygon is not a triangle, then it does not have exactly 3 sides. That is the inverse of that original. Okay? I negate both the hypothesis and conclusion. Now, write it down. Make sure you write the whole thing. Some people go, it's so hard. Trust me. Trust me. Write it down. Learn it now. Make sure you're successful on the quiz we have tomorrow. And we have a quiz on Friday. The quiz we have tomorrow is a 3rd one of the week to make sure we get it. Okay? And I'm making sure you get it because I actually have a quiz that's going to be with your grade along with, you know, for the rest of the year. I want to make sure, you know, the rest of the semester that it's successful. If your goal isn't that, tell me. I won't work so hard for you. Okay? It'll alleviate my time. Bloom, really, you know, I don't want to really pass the class. I don't want to be that successful. Don't waste your time with me. Okay? But remember, if you come up to that, I'm going to shoot an email home, or I'm going to get you to sign something, and I'll be fine. You can do this again, because it's awesome the second time. Okay? Or the 3rd. I've had people in 3 times. Okay? Okay. Converse. I switch these. This goes here. This goes here. Okay? It's a converse. I switch the hypothesis and conclusion. Maybe. He's got to find it in the right spots. Okay, that's where I'm going. It's a formula. Inverse, converse, contrapositive. Write them down. I have people that have been on the fence about committing to getting notes done because it's too hard, and boy, I'm telling you, it's not looking good for what I get on the quiz so far. Okay, quiz results are out. You'll be able to check those after notes. You've been able to check them all day. And you can check your responses. You can check the right answers. I think I put them in, especially in the last 4 responses. If you have a red box around one of your responses, but you got the full credit, I overwrote what the program was doing because how you phrased it or how you wrote something didn't work, okay, for it to accept it, but it was right. So just know that was the case, and I had to do that by hand for everybody, okay, putting in your scores on that. So that's what happened on that as we go through. So make sure you know you're ready. Okay, that was a good review for us to get ready for the one we're going to take tomorrow and the one we're going to take on Friday. Okay, it might seem overly crazy, but if I don't have you practice, you'll never see it the first time, will you? Just like those pictures, we got to practice. Contrapositive, negate and switch. So I negate and switch. So it's really a negation on the converse. So I take my converse and I negate in place, and that's the difference. That's a contrapositive. Stroud, do it later after notes. Thank you. Contrapositive. You have a converse. You have your original statement. I want to talk about truth values. We have it in notes that the original statement and the contrapositive always have the same truth value, no matter what. And the inverse and the converse always have the same truth value, no matter what. So when we write a biconditional, when we're comparing the original statement and the converse, we must consider the statements separately. Just because we know one's true doesn't guarantee the other one is. Okay? If I know they come from a true biconditional, I know both statements are true. But if I don't know that conditional they come from, or the biconditional they come from is absolutely true, I got to check them separately. That's where we go to the forward and reverse sense. The forward is the original, and the reverse is the converse of the original. So now, biconditional. A polygon is a triangle if and only if it has exactly 3 sides. Done. Okay? It's a combination of P implies Q and Q implies P. Are there any questions about what we're doing and how we're getting it done? Here's this next section. When I come up with people and they go, oh, seriously, Bloom? Algebra junk? Seriously? Okay, how do I know something's not going to be equal to something else in an algebra sentence? What should I use? What type of sign? If it's going to be not equal to it, is there a sign that I have in algebra? Yeah. What is it?
It does not equal sign.
Yeah, it's a not equal sign. I just put a line through an equal sign. This is how cool this is. The inverse. If x squared is not equal to 144, because in the inverse I rewrite it in the same order, I just negate. Then x is not equal to 12, or x is not equal to negative 12. That's it, done. People are like, no way, it's that fast? You just got to know that I'm saying the not by saying not equal. It just happens to be not equal. The converse. What? The converse? I just flip. The conclusion. All right, let's make that a different color. And the hypothesis. That's it. That's all I'm going to do. So they're going to split. And I'm going to do it in blue. What the heck? So I got if x equal 12 or x equal negative 12, then, make sure I put a comma there, x squared is equal to 144. And remember, that's where that came from. And, whoop, I got to do that. This is where this came from. So I flip-flopped them. That's what a converse does. Okay? The contrapositive is the negation on the converse. Okay, the negation on the converse. So I negate the converse. If x is not equal to 12 or x is not equal to negative 12, then x squared is not equal to 144. These rules have a formula, okay? They are straight up formula type rules. You're asked to write one, based on the rule, you get it done. If you're not sure how to apply it, that's why I'm here. We're here to review, we're here to make sure you gets it. But again, a biconditional is a combination of your converse rule and your original. Okay? Your biconditional is, well, you know, I've got x squared equal 144 if and only if x equals 12 or x equals negative 12. Biconditional is done. Notice I just dropped if, and in place of then I put if and only if. That's the rule. Okay? So we've talked about biconditionals, if and only if, how to write them, that a good biconditional is a true forward and reverse. Making sure you're paying attention to notation. Use the arrowheads. If you just give me dashes, it will be wrong. Okay, don't just give me dashes. Make sure you have a purpose for writing things in. Okay? Now, I've been talking about a good definition. So let's talk about good definition just to make sure. Good definitions are clearly understood terms. Okay? They're precise. They're not wordy. If they are wordy, rework it to make it easier. Make it more realistic as you're going. Okay? Now, I just got a couple left there. We'll get that last one on there. Now, keep in mind, this is our last part of notes is about good definitions. So I'm going to give you a statement, and I'm going to ask you to do something with it. Okay? So, I got the original statement, and I should probably erase this because I don't want you guys to have that stuff on there. But here's the deal. If two angles are complementary, then their measures have a sum of 90 degrees. I'm asking you to do the reverse of it. Reverse is, I got an AKA for reverse. It's converse, right? Reverse, converse of the original statement. So write the converse. So I should be taking this stuff and putting it down here, and I should be taking this stuff and putting it over here to get it done. Okay, because it's the converse of the original statement. That's the reverse. I want to do that. That's this one. Oops, sorry. And that one. Okay. Now, check out what I did. I substituted two angle in there. I don't know why I went from there to they, but I did. It's not a big deal. It's not too much of a stretch. Go from there to they. Now, are you okay with the converse? Is it converse true? I'm asking you to discern. Two angles are complementary, okay. Then there's some measures and some to 90 degrees. Well, that's the way Bloom defined it. Well, if two angles measures have a sum of 90 degrees, then they're complementary. Well, that works too. Well, this is a good definition, okay. So I can write it as a biconditional that way. Two angles are complementary if and only if the measure of the angles have a sum of 90 degrees. And that's it, okay. Now, if you're at home, you got to print off your assignment. If you're here, you got your assignment in your hands. Check online. Your quiz is done. It's graded. Check out your solutions and the corrections I suggest. And make sure you know how to write the inverse, converse, and contrapositive of an original if-then statement. Make sure you know how to write a statement into if-then form, and you know how to come about a good definition in a biconditional and how to write it in forward and reverse and use those when you're writing that good biconditional. Okay, those are it. Those are the highlights. I hope things are going well.